Okay.
Okay, can you confirm that you can hear me well?
Perfectly. Yeah.
Okay, that's good. So, the topic that we're going to talk about today is called Java cast, right?
Java what?
Java casting. So
Caspin?
basically, casting to cast.
Okay. Casting. Cast. Okay.
Yes, yes. Uh, it's just a very short topic. We're just gonna run through it. Because the goal is that we talk about the operators today, right? So,
Yes.
uh, Java casting, right? So, what is to cast? A casting is basically, remember that we talked about data types yesterday.
Mhm.
Yes, and we basically say that, we have primitive data types and we have reference data types, right? So
Yes.
primitive data types, trying to make a comment here. So primitive, if we're talking about primitive data types, we're talking about data types that were given by Java. Were given by Java. And these are the data types that come with the Java program, right? They're already defined in Java. And whenever we're talking about data types, we're talking about the way this information is stored inside the computer, right?
Okay.
So the types of primitive data types I'll just touch, like high level of what we're doing. Those are things like integer, longs, float, double, um, characters. They are all primitive data types. And the only reference data type is the string. Why? We are going to
Okay.
talk about this on another a lesson in front, but a string is called a reference data type because of the way information is stored inside a string.
String
Right.
is a reference data type, correct?
Yes, because whenever we are calling a string, we're actually just making a reference to the memory location, not the actual location where something is stored. Right. Uh, Let me give you an
Okay.
example.
So primitive. Can you? Primitive has integer, float, right? All the
Yeah.
other ones you gave me, correct?
Yep. It
And
is
character.
integer. It is character. It has floats. It has doubles. A double is just the same as an integer, but those integers that store a big number. Mm.
Okay.
And it stores, double store a bigger number than an integer. Usually, though, most of the code we're going to write is going to be uh, using primitive data types, right? Then reference data type.
Okay.
Uh, Whenever I'm saying a reference data type, give me an example of the reference data type. The biggest example is a string, right? Why is that? It's because let me give you an example here, right? So right now I'm gonna draw a box, right? I have one box. I have another box. Then I have another box, right? So my first box, I'll call it an int, right? My second box, I'll call it a float. This guy, I'll call it a character. In this guy, I'll call it a string, right? This is gonna be string, right? Like that. So what do we mean when we talk about data type? What do we mean? What we mean is these guys over here that are in green, right?
Mhm.
It means when you go for a primitive data type, if you go inside the computer, inside memory, you're going to see the exact location where that information is saved, right? So here, if you say int is equals to 5, right?
Mhm.
If you go to the exact location, yeah, for this guy, you're going to see the 5 being stored there, right?
Okay.
But with a string is different. So when you create a string and we call it alpha, right?
Mhm.
If we go to look into the memory location where the string is stored, you are going to realize that it's not going to be stored as alpha. Instead, when you look into there, you're going to see a reference to another place where the name is actually stored.
Wow.
So that's why the strings are called reference. Why? Because we're making a reference to get that value. Do that make sense?
Okay. That makes sense.
Right. For primitive, this Java gives us like that. They come with Java. If you go to the actual storage, you're going to find those values. For reference types, the values that you get in terms of storage is stored as a reference to, you know, when you go to this location, you're going to find a reference to where the actual object is stored or the actual thing is stored inside.
Okay.
Remember, I told you variables are like cups, and integers, you're telling it what type of a cup it is. Think about yourself as you are going to, to drink at a club, right?
Yep.
And then you go there and you say you want wine, and they bring the wine in a champagne bottle, in a short glass. It doesn't make any sense, right?
Yes.
When you order a wine, you expect a wine glass. So that's the same thing here. When you create a variable of integer, it's expecting the type to be a number. If you say float, it's expecting the type to be a float. If you say character, it's expecting the character to be the one being put in that container, right?
Yeah.
Yeah. So basically,
Okay.
now what is casting, right? Casting is then what is casting? So now the topic of today is casting. Let me wrap this. So casting is converting one. Casting is basically converting one type to another type. What do I mean by
One
that?
type to another.
Yes. Like, so let's look at numbers, right? We say the float is a number, right?
Mm-hmm. Mm-hmm.
That ends with an F, right?
Decimal, right?
It's a decimal number that ends with the F, right?
Yes.
So if I create a variable and I call it age, or let me call it wage, meaning what you get paid, right? And then
Mhm.
we say is equals to 20, right?
Yeah.
Right?
Yeah.
Right. So wage here we have the wage, and the wage is equals to 20. Now, what we're trying to do here when we're casting is now we're trying to convert that into something else, right? Let's convert this into like, let me create something like, let me create another variable that is a double, right? I'm gonna create a double.
Mhm.
A double is just like a float, but it's you put a D at the end. And doubles take a long decimal, like 9.43682, up to about
Oh,
14
okay.
types, right?
Oh,
Float,
okay.
we are using it when we are using,
Just
2.03.
2.3 or 4.7.
Yeah, but a double is when we're now using like a 9.802346.2, you know, big numbers like that,
Okay.
right? Then I say this is my double or my number. Let me just say my number. So when I say this guy to be my number, right? This one, I can come here and cut by putting this in quotation, by putting double in quotation marks, and by giving it the variable wage. Look at that. You see now? So now when I come here and I print out a wage, I'm coming here, I'm printing out the wage value, right? Wage int value. And then I'm going to do.
Okay, I'm getting lost now.
You're getting lost. Okay, let's take a step
Ye-
back. We created a variable called wage and we put the number 20 in, right?
I got that part here.
And I said casting
So-
is converting from one primitive data type to another primitive data. Right, meaning
Okay.
we're trying to convert this integer to a double. Right, this right now is a type. This right now this right now is a type integer, right?
Mhm.
You agree? Because
Yes.
you see it's int here, but I want it to be
Right.
to be this type. So I create another variable, I call it my number. And then now when I come here, for now I'm showing you the process of, but then usually what we're doing here is called automatic casting, because we're actually moving from an integer which is small to a double which is big. So usually when you're moving from a smaller type to a bigger type, happens automatically, right? But I'm just trying to demonstrate something to you. So now we're just printing this wage, right? This is what, okay, maybe that one is confusing. Then we're just printing out this wage. You see this wage?
Mm-hmm.
We're trying to print it out, right? Now, right now, what value do we have at the wage? We just have a 20, right?
Mm-hmm.
And then I came here and I made it a double, and I made wage double. So now what I need to print is this one.
Right.
The new variable, my number.
Okay.
Right, that's the one I'm printing.
Okay.
Now, a shortcut to run the page that you are in, if you have a lot of files open, you either use this one, or this one. Oh, we haven't set it up. So it's this one or this one. So what you do is the shortcut in Windows is, I think it's Control Shift F10. Yes, Control Shift F10, it actually runs your project. So I would suggest you write that down. Control Shift F10. Look at my answer. It's 20.0. You see that?
Yes.
Why? But then it's supposed to be 20 because the number I put is 20. The reason is because when it got here, wage, this guy, got converted to a double. And a double stores numbers as decimal.
But when you say double, I thought it was supposed to 20 times 2 make it 40.
No.
Or is it, oh, double? Okay, double is a variable, right?
A double is just a data type.
Okay.
Right, a double is just
So
a
when you
data type.
say equals to bracket double wage, why did you put brackets in a double there? That confused me.
Here, this is what you do when you're casting.
Oh,
So
you have
cast,
to put the bracket.
You put the bracket and you put the type that you want to cast to.
Beside it.
Yes, but now the rule that I want you to follow is so in the data types that I showed you yesterday, right?
Mhm.
There are a number of them that we didn't cover. So there is something called a byte also, and there's something called a long, and there's something called a short. All of these just store different flavor of number, right? They are all of them are just primitive type. For example, you can say short, you see? You can say long. They are just ways of storing a number. You can say byte. Byte is the smallest. So when you're trying to put a variable that is very small, that can fit. So literally what happens is that all of these guys and int, byte, long, short, they're all primitive data types, right? That's why even when you see the color, they are orange.
So the short is equals to 12. Short is longer,
no,
or
so I'm just using it as I'm just demonstrating here. This is just a demonstration of these things in here. And if you want to learn more about something in Java, to go more into it, Control Shift. If you press Control Shift and then you click inside it, will it open? Ah, it didn't open. Usually it tends to open and give you information about that. Right. So if you go to if you go
I think
back,
I can find it on the W3 that you sent the school.
yes. That's where I'm trying to show you where that is. Okay. Here is everything explained here. I'm gonna okay, I'm gonna send it in here. So this one is basically showing you this one is showing you this shows you the type in the group. I hope they will allow me to post this. Yes. Okay. Check in the group. There's something I posted in the group.
Okay, I see the chat.
Can you see the new thing I put on the in here?
Yeah.
You can see the white data type size description. Can you see that?
Yes, I see that. Data type, size, and description. Yeah. Is that
Yes.
what you sent? I think it came to my. Okay,
Yes,
I
that's
see
what
it
I
right
sent.
here.
So that these are the
Okay.
data types. These are the primitive data type. Right. All of them.
Okay.
Right. Here it tells you a byte is size 1 byte and it stores numbers between 1 to 128 to 127. Minus 128 to minus 127. You see that? That means
I see it.
when you're creating a variable, which is a number, and if you use byte, let me give you an example. In byte here, if I put 128 like that, it gives me an error, you see?
Ah.
Yes, and it tells me to cast to byte. And if I click here, you see how it casted. You get it?
You say you clicked where?
Let me show you. Byte. A byte is just an integer, but it's just a variable for you to use when you want to use a smaller variable.
Right.
Right. Remember, I said variables are just storages. And these storages, you want to tell them
Mhm.
first before you store something in that, hey, I want to store this thing. And when you tell the name, it keeps the location and the size that it has to give you.
Okay.
Right? Like you say, small, medium, large. When you get to a restaurant, that's how these variables are. So whenever you say short, right? Like what I'm doing here, line 15, right? If I say short, already in my computer, there is a memory that gets created, and the memory is gonna be 2 bytes. And the 2 bytes, they store information. They'll only store a number that is between 32,767 to minus 32,767. If I put a number that is above that, it's not gonna work.
Okay.
Why? Because the storage will be full. It's like, hey, this guy ordered a small fries, but he wants to eat a large fry. It doesn't work like that.
Okay.
So this is like going to a restaurant. Using variables is like going to a restaurant. You have to say the container that you want, and then you put the value that you want inside the container, right?
Okay.
Like, so the primitive data types, I told you, they are bytes, short, int, long, float, and double. And all of them, they store numbers, but different flavors of numbers.
Okay.
So whenever you say int, see here when you say int, right here, the space that you create in an int, whatever number you put should be around 2,147,000. If you have a variable that is more than 2 billion, and you put here, let me give you an example. I want to put 4 billion. Right? Look at that. So my variable is 4 billion. It gives me an error. Why? Because it's saying, hey, an integer can only store a number that is between 2 billion, 2.1 billion, and minus 2.1 billion. The number you stored is above. See that? Integer number is too large. You see what it's saying?
Okay.
That's what it's saying.
Okay. So basically what you're explaining is anything primitive data type from the integer, the long, the short, you have to follow the rule of the numbers that's been given. If not, you get an error.
Yes,
right?
yes. That means those variables, they only store a particular amount that you want, right? For example, when you're doing a float is 4 bytes, right? So what does a float does? Bytes is actually size. It tells us how big something is, right? How big something is. Like right now, we talk about terabytes, gigabytes, right? So byte is like a measure of size. We use bytes to measure size. Right now, when I ask you how big is your phone, you tell me my phone is 20 gig, right?
Yes.
That's the same thing. A byte is a smaller version of a gig.
Okay.
I think a gig is almost like I don't remember, but it's a lot of bytes.
So byte is smaller.
Byte is smaller, yeah. And there's something smaller than bytes, which are called bits. 1 bit. Yeah.
What?
So they're called bits, like BIT. So you start from bits, bytes, and then you go to like megabytes. Yes.
Okay.
You go to kilobytes, you go to gigabytes, and it goes up, nanobytes.
Okay.
And going up. That's basically says size. So all these primitive data type, they come with a particular size. So whenever you say float, that means you are reserving a particular size inside the computer memory. So that's why whatever you have to put should fit inside that cap.
Okay. So going back to that casting is one I'm a little confused.
Yes.
You explained this
So,
quite right. The integer float. I get it. Got those ones.
Okay. Now, casting is when you are moving from one data type to another. For example, you have a variable that is an integer, but you want to look at it as a float. So you cast that integer to a float. And I gave you an example. This integer is number 5, right? This integer is number 5, right? And in here, whenever you're moving from there are two, when you're talking about casting, right? Whenever you're moving from a smaller size to a bigger size, remember we say these things have sizes, right? Like,
Right.
let me bring that back. Let me okay. So we talked about size, right? This is the size. You see that? That's a size, right? So it means if I have a variable called A, and I want this variable to become B, right? If A is a byte, you know what I'm trying to write? Okay. It's a byte, and B is an integer, right? Now, a byte is smaller than an integer, right? We agree. A byte is 1,
Yes.
an integer is 4, right? So when you're converting a number, which is a variable, from a byte to an integer, it happens automatically. Yeah. It happens automatically. The computer will do it for you.
Okay.
Right? The computer will do it for you. That is what is called it's called widening casting. That's what it's called. Meaning we're widening it from a smaller to a bigger one. So that's what casting is. It's just converting.
Widening, like making it wide, right?
Yes, why? Because we're moving from a smaller to a bigger data type.
Bigger one.
So this one in memory will have 1 byte, right? 1 bit, and the integer will have 4 bits, right? So we have a variable that we stored here, and we want to move it to here. It happens automatically. That's the widening cast. Right. For example, when you're moving from an integer, which is 4 byte, to a long, which is 8 byte, right? That's widening cast. Right. It happens automatically.
So what if you are moving? So what if you are moving from integer to a short? What do you call that?
Yeah, if you're moving from
not going to be widening anymore
to short, right? That's called narrowing casting.
Narrowing. Okay, good.
Yes, and that is the one that you do something like this. You have your variable here, int x, right, is equals to 10, right? Int x is equals to 10. Okay, hold on 1 second. Hold on. Okay, apologies for that.
No, fine.
Okay, so now we have a variable x is equals to 10, right?
Mm-hmm.
And we have a variable which is a byte, we call it y. This is y. Yep. Y is equals to like 4, right? Right. So now when we're doing narrowing, that means we're trying to move. Actually, let's just do a byte. Let's just do byte. So don't mind this one, right? Let's look at this one. We have a variable called a byte. When we're narrowing, want to move from bigger to smaller, right? So we have a variable called byte. This example won't come out. Okay, so int x is equals to 10, right? So now we want to move this variable that we have here to become a byte, right? And remember, a byte is smaller than an integer, right? So when we're casting here, we're going behind. We're moving from integer to byte. So we're going behind. That's the narrowing casting. Right. So the method you do when you are narrowing casting, that means when you are moving, when you're ever having to move from a bigger variable to a smaller variable, is this. This is the formula that you follow. You first put the one that you wanna, you first put the one that you wanna do, right? In x is equals to 10, right? And then now we create a variable called byte like this, because we want to convert it into a byte, right? And our variable is called z is equals to, then we put a bracket. And in the bracket here, we then put the one that we want to convert it to a byte. You see that? And then we give it the x. This is x. So in this case, when z is looked at, z becomes a byte, where we converted this x that was an integer into a byte by casting. This is what casting is. That is what narrow casting is.
You
I
lost
lost
me
you.
on the narrow.
Okay, no problem. It's a, let me go ahead and let me do this. Let me show you in code. It's more easier to explain. Let me show you in code. So I use the mouse to write. So that's why I look like I can't write to save my life. Yep. And I'll make sure I'll include this into the notes I'm gonna send. Okay. What does the example that I was showing you? I'm gonna go ahead and show you, right? We have a variable, and we say our variable is the type of integer, right? Int. And age is equals to, we call it 10, right? And we want this integer to change this value of age to become a byte, because we know nobody can grow up to around 128, right? We know that like a byte is 128, 127 actually. So it's on rare occasion that we have people growing up until 128, 127. So what we do, we say, okay, let's go ahead and save space in this computer by changing this variable into a byte, right? So I'll create a variable byte, because the primitive data type, we know when you're creating a variable, you start by saying what type of variable it is. right? And then you follow with the variable name.
Mhm.
We'll just say something like, updated age, right?
Mhm.
Is equals to. Now, because an integer is bigger than a byte, that means we are going behind.
Mhm.
We are narrowing casting. Whenever you're narrowing casting,
Okay.
this is what you do. You come here, you put a bracket, and then you put the
Mhm.
type that you want to convert this to, right? You want to convert it to a byte, and you put the value that you want to convert, like that. You see
Okay.
that?
So we are narrowing from integer to byte, correct?
Yes. So now age is no longer an integer. Age is now a byte.
Oh, that makes sense. Okay, you know what?
Right.
Moving forward, be explaining like this. Let's be on the platform. I understand what you just. So if you're narrowing, since integer is higher than byte,
Yes.
you know, yeah. So technically, we're gonna narrow down to a byte, which
Mhm.
on the value, byte is the one that we want to narrow. So that's why it's in bracket, and the word
Exactly.
age is the one we are narrowing from.
Exactly. So now when we print this updated age over here, right? Control
So
Shift
I'm
F10.
expecting it should give us the
No, it will give
should
us
it
the
give us the
same
byte,
value, like it will give us the same
the
value
value of the
because
age. Okay.
yes, you see, it gave us 10, but this 10 is now a is now of type. This age is no longer an integer. It's now a byte. So inside the computer, this age is now stored now as a byte.
It's a byte.
That means we have saved
See,
space.
fantastic, fantastic. I just understand it.
You understand it
Okay.
now? So,
Okay. So
but
when we go from higher number to lower number, we are narrowing. But
exactly,
when we
that's why
go
we
from
use,
from
that's where,
lower to higher, we are widening.
yes, and widening happens automatically,
Okay,
right?
can you show me widening? Let me see.
Okay, to widen, so we are trying to move from an integer to a log, right? So I've created a variable called size. Okay, let me do this so that when you are reading the video, when you are watching the video, this is an example of narrowing casting. Right, and then now this is an example of widening. And widening casting is also, hey, I can't spell to save my life. Wide should be widening. How do you even
And you
widening?
got
Yeah, I think it's
YIDENIN. So
it's yeah,
YIDENING,
like
something like
this.
that. Yeah.
Widening, or it's
Okay.
called automatic. Why is it called automatic casting? Because it happens automatically without you needing to do what we did over here, right? Like, for example, we're moving from an integer. This is size 11, right? And we want to move to a long, right? Want to move to a long. And we
And
say
long is
updated.
higher than integer, correct?
Yes.
Okay.
Nice. I'll bring this to you. You see, the long is 8.
Yes.
You see, the long is 8. And the integer is 4 bytes. So that means the long is higher, right, than an integer. So we're moving from a smaller one to a bigger one. Yeah. So basically, what does it mean? If you think about it, think about logical, right? We're inside the restaurant. If you are ordering, if you order a small let's assume we ordered a small dish, right? For you to get a larger dish, to get like a large dish, most likely you are gonna need to pay extra, right? You're gonna need to pay extra. Like you have to pay extra. Hey, we give you extra money. I wanna to get a large one, right? And they'll gladly do it for you, right? But
Right.
now, if you had a larger one and you wanted a smaller one, that means you now need like a bigger plate to put that food inside. So that's why you have to then cast it. We're casting it because we're moving from a larger to a smaller one. But if we're moving from smaller to larger, it's actually easy. The computer does it for you. Now, let me explain this simpler. You see this example in line 22. Updated size is equals to, we created a long variable called updated size, right? Is equals to size. Look at that. No error, nothing. You see that?
Whoa.
I did not need to put here and say long. Even if you put here, it doesn't really do anything. When something is dark like this, it means it's not used.
Oh.
You see? Why? Because we are moving from
So
a smaller one to a bigger one, right? So it does it automatically for you. So there's no need for you to write this thing. So that's why you just
you
write
don't need the
layer.
you don't need the bracket, nothing.
You don't need nothing if you're moving from a smaller to a bigger one.
Okay. Okay.
Yeah.
So if we run it, so let me assume if we run it, it's gonna
Let's say updated size. Now this one is gonna be shown as a long.
it's gonna be what?
And remember, for a float, you have an F at the end.
Hmm?
Do you remember when you write a float, you should put an F at the end?
Yes.
When you write a long, I'll show you an example of a long and yeah, an example of a long after this one. So you see, this 11 now is stored. The size is now stored as a long. That means you are now using 8 bytes. Here, we are using 4 bytes, right? Now, after you cast it here, you're now using 8 bytes. You're using more space.
Okay. But when you run it, it will give you the same answer as 11 automatically.
Yes, it basically just gives you the actual, it gives
So
you
the
this value.
integer will change. The integer will change to a long, correct?
Yes, the integer, good. The integer changes to a long. So why is this important, right? Why is casting important? Casting is important because at some point when you're writing code, you're going to need to declare a variable as one thing, but then want to use it as another type, right?
Okay.
So that's when you go ahead and cast it. Like I told you, usually people don't live up to 127 years old. So if you're writing code and then you have age as an integer, and then for some reason you're creating an algorithm that requires you to use a long, you can then change that age to become a long by casting.
That makes sense.
Yes, but if you're moving from small to big, let me say, if you're moving from small,
widen.
From small to big, if you're moving from small to big, this is the widening, because you're widening. Technically, to know coding is very simple. You know what you're widening? You're widening the memory. Right, the way these data types are stored, you're widening it. And it does automatically. So whenever I say, if I give you an exam next week and say, create a variable code size and cast it to a law. This is what I'm asking for.
Okay.
And if I ask you what casting is, I'm expecting you to give me an example of the two types of casting. Narrowing, or moving from a big to small. Right? So this is big to
Then
small.
widening is small to big.
To big, yeah. And this one, you then need to use a casting by using the parentheses. These guys. Hmm. That makes sense.
Yes, it makes so much sense.
Makes so much
Yeah,
sense.
I'll learn better with. I guess I'm a visual learner.
Yep, that's good. That's good. Okay, now, any questions on casting?
No, so
Okay,
far.
so far. Now, we are going to move to Java operators.
Before you enter that one, can I take a 5 minute 5 minute break?
Yeah, okay. So I'm going to stop and then start a new one so that we have two different videos instead of one long one. Yeah, take a 5 minute break. I'll send you the updated Zoom link.
You don't need to stop the video. I mean, you can continue, right?
I want to keep the lesson separately so that it's easy.
Okay.
So
Okay.
I'll, okay, good. Bye-bye. I will send you in 5 minutes. And you
Okay.
join. Okay, good. Bye-bye.
All right.